Assalamualaikum warahmatullahi wabarakatuh. I be to Dr. Jeffrey. My name is Ungku Aziz Syukry based Ungku Alli Korish. And today I will be presenting about my research project 2 with a title of The Corrosivity of Earthing Electrode, Galvanized Stranded Wire in Various Locations for TNB Transmission Tower. So these are my poster and I will be explaining 4 parts starting with introduction, methodology, result discussions and conclusion. Let's look at the introduction first. As for the introductions, all TNB transmission towers are equipped with lightning protection system to protect the tower from lightning strikes. One of the elements in lightning protection system is earthing electrode. This earthing electrode is buried into the soil under transmission tower, and the function is to immerse the lightning current into the earth. And one of the common earthing electrode used in industry are galvanized stranded wire. This galvanized stranded wire is widely used in earthing electrode due to cost effective. However, the metal is not a long-term usage due to low in corrosion resistance. Next, for the problem statement is due to the extended times of being submerged in soil, earthing electrode is threatened to soil corrosion. It could damage the lightning protection system and increase the risk of power trips. There are two objectives in this research. First is to analyze the soil type through soil texture analysis and to characterize the soil properties in terms of iron content, sulfur and chloride by using CHONS analyzer and X-ray diffraction. Second is to determine the corrosion rate of galvanized wire by weight loss method in accordance with ASTM G103. For the methodology, so this is the flowchart of the whole process. First, for the soil sampling, there are 4 locations that will be chosen for soil sampling. First is Gelang Patah, Johor, Marang Terengganu, Paya Rumput, Melaka, and Kampung Gajah, Perak. So next, the soil will undergo characterization of soil. First is the soil texture analysis. So the function of soil texture analysis is to determine the physical characteristic of the soil. So the method that we'll be using is pipette methods. So next is CHONS analyzer. So the function of CHONS analyzer is to determine the content of carbon, hydrogen, oxygen, nitrogen, and sulfur element. So the method of CHONS analyzer is combustion of soil in analyzer. So lastly is X-ray diffractometer (SRD). So the function of SRD is to determine the soil mineral. Next, for the soil corrosion test, there are 2 tests that will be tested. First is the control test, which is the metal used is carbon steel. Next is the corrosion test, in which the galvanized stranded wire itself. So the control test is tested to obtain the corrosion rate of carbon steel, and the corrosion rate will be used as basis to calculate the lifespan of galvanized stranded wire. So when both of the metal have been tested, the weight loss measurement will take place. So let's go with the salt texture analysis procedure. So for the salt texture analysis procedure, first we need to put 50 grams of salt into a beaker and then add 5 milliliter of dispersing agent and then add distilled water until 500 milliliter and then take 2 milliliter of the solution using pipette. So the solution will undergo the experiment to obtain the the size of the salt and to characterize the size of the soil itself. So next is the CHONS analyzer. First, we need to put 10 mg of soil into aluminium tin and then put into auto sampler above the analyzer and then run, and the result will display on the monitor. That's for the SRD procedure. First, we need to grind the soil, put 20 mg of soil into the slide and place the slide at the sample holder. Set the diffractometer at 40 kV and 40 mA and then start angle and end angle at 10 to 100 degree. So as for the carbon steel metal preparations, the carbon steel used is SCC5. So the approximate dimension is 24 mm length, 2.7 mm width and times with 34 mm height. As for the galvanized standard wire metal preparations, first the metal will cut into 6 cm length, coat upper and bottom side with anti-corrosion spray, and then cure the metal at 200 degrees C using microwave, and then weigh and record the dimensions and store in Ziploc bag. As for the soil preparation, use 1.3 box container, fill the soil half of the container, and then put the metal in the center of the soil, and then fill the soil until the soil fill container weight 1440 kg. Fill the remaining space of container with water sample until fully inundated, and then leave the metal for 40 days. So after 14 days, the weight loss method will take place. As for the galvanized wire, retrieve the metal from the container, rinse and record the weight of the metal, place into ultrasonic cleaner, dry and weigh the weight, and record the weight, and then repeat until the weight of the metal is less than 0.002 gram. Next is for the carbon steels. First, we need to retrieve the metal from the container, same as the galvanized wire procedure. Next, rinse and record the weight of the metal. Next, dip into 50 ml of cloud solution for 30 seconds, and then transfer and dip into 200 ml of distilled water for 10 seconds, and then dip into 200 ml of acetone for 10 seconds, and then repeat until the weight of the metal is less than 0.002 gram. So after we have obtained the final weight of the metal, we can calculate the corrosion rate of the metal. So the formula of the corrosion rate is uh, 87,600. This is the constant times with the final weight divided with the density times with exposure hour, and then times with the surface area. As for the lifespan, the lifespan is the life can be calculated with the lifespan of zinc plus with the lifespan of carbon steel. So the formula is the thickness divided with corrosion rate of galvanized. The thickness of the galvanized stranded wire divided with the corrosion rate of galvanized wire plus with the diameter of galvanized wire minus with thickness divided with 2, and then divided all of this with the corrosion rate of carbon steel. So we can get the lifespan of the galvanized stranded wire. Next, we proceed with the result and discussions for soil texture analysis. Soil texture analysis is to determine the size, physical characteristic of soil. So this analysis does not consider organic matter. So from the table, the numbers here is the soil composition from soil texture analysis. As for the paya rumput, the composition of sand is 46, the composition of seed is 55%, and the composition of clay is 17.5%. So by using soil texture diagram, triangle diagram, we can calculate that and know the soil type of paya rumput is loam soil. The red dotted here. So followed by with marang locations, the soil type is sandy loam, gelang patah is clay, and kapung gajah is sandy clay. Next is the CHONS analyzer. So the function of CHONS analyzer is to obtain the carbon, nitrogen, hydrogen, and sulfur content. Not just that, so the soil with more than 65% of carbon content is considered as peat soil. So from the table, it shows that paya rumput and gelang patah has carbon content with more than 65%. So therefore, these two locations is peat soil. Moreover, for the four location, there is for the sulfur content, the sulfur is not detected by the analyzer. Next is the X-ray diffraction analysis. So this SRD pattern of soil at 5 different locations are illustrated in this graph. So for the two theta peaks for kaolinite were found at 12.2 degree 12.2 degree for gelang patah away from metal, kapung gajah, and paya rumput. But there were no kaolinite be found at marang and gelang patah. So kaolinite can form in soils from aluminium and silica released by the weathering of primary and secondary minerals. Moreover, there is another more intense deflection found at 21.2 degree, confirms the presence of albite and muscovite. So muscovite is one of the mica mineral present in the soil that contains potassium and aluminium. Moreover, there are also strong diffraction peaks at 2 theta 26, 30, 36, 46, 50, 60, and 68 degree are all detected in all five locations. So these peaks shows the presence of quartz, which is it is most widely recognized and present in most soil. So these four minerals are natural minerals that exist in every soil. Next is the corrosion test results. So this is the graph of corrosion rate and lifespan of the metal. So the corrosion rate of galvanized standard wire at Gelang Patah is 0.025 mm per year, while at Marang is 0.017, at Kampung Gajah is 0.026 mm per year, and payung rumput is 0.022 mm per year. So from overview point, we can see that Kampung Gajah has the highest corrosion rate, which is 0.026 mm per year, with lifespan of metal around 8 years, while the lowest corrosion rate is at Marang, which is 0.017 mm per year, with metal lifespan of 12 years. So we can see that the corrosion rate of all these four locations is more or less the same. So this resulted only in a 0.0009 mm per year value difference. And the lifespan is between 8 to 12 years, and there is no huge gap for corrosion rate and lifespan. So from the graph, we can see that Gelang Patah and Kampung Gajah has higher corrosion rate compared to Marang and Paya Rumput. So this is because the soil type of these two locations, Gelang Patah and Kampung Gajah, are under clay soil. So clay soil has smaller in particle size compared to the other soil. So this makes the clay soil good in water holding capacity and low in soil resistivity. So this will lead to a high corrosion due to high soil conductivity and better electrochemical corrosion process. So therefore, there is a direct correlation between soil type and corrosion rate. So next is the graph of pH profile for 10 days. So from the graph, we can see that the pH is increases from day 1 to day 6, and then it will remain stagnant until day 10. So the pattern shows that the corrosion is happen. So low soil pH indicates in high hydrogen ion. As time passes, the pH will increase because the hydrogen ion is being used for reduction process to convert the hydrogen ion into hydrogen atom. So we can see that the average pH value of location Gelang Patah, Marang and Kampung Gajah were in the range between 6.3 to 6.91. Besides, Paya Rumput location has the lowest pH value to the other three locations. However, the acidic pH at Paya Rumput shows the result against theoretical, where it was supposed to be severe corrosion attack. Therefore, there is no direct correlation between pH and corrosion rate. So next is the discussion between corrosion rate and soil resistance. From literature, low soil resistivity indicates high electrochemical activities, resulting in a high corrosion rate. So from the graph, it shows that the soil resistance of Gelang Patah, Marang, Kampung Gajah, and Paya Rumput are 0.05 ohm centimeter, 0.08 ohm centimeter, 6.5 ohm centimeter, and 6.24 ohm centimeter. So it can be seen that Gelang Patah and Marang have really low soil resistivity as compared to Kampung Gajah and Paya Rumput. However, the graph of corrosion rates shows that there is no prominent gap between location with high soil resistivity and low soil resistivity. Therefore, there is no clear correlation between corrosion rate and soil resistance. So, as for the conclusion, the soil type of Paya Rumput, Marang, Galang Patah, and Kapung Gajah are loam, sandy loam, clay, and sandy clay. So next, payung rumput and gelang patah has more than 65% of carbon content, so both locations considered as peat soil. Not just that, sulfur is not detected by the analyzer. Next is the all locations have quartz, kaolinite, albite and muscovite mineral. So these four minerals are the common mineral exist in every soil. So next is the corrosion rate of galvanized wire at Gelang Patah, Marang, Kampung Gajah and Payung Rumput are 0.025 mm per year, 0.017 mm per year, 0.026 mm per year and 0.022 mm per year. We can see that all the corrosion rates for these four locations behave more or less the same. So lastly, the lifespan of galvanized wire at Gelang Patah, Marang, Kampung Gajah and Payung Rumput are 9 years, 12 years, 8 years and 10 years. So that's all from me. Thank you.